Okay. So today is all about inequalities, which are, if you remember from, I don't know, like second grade, are the alligator signs.
I just sat down.
So there's a particular way to read them. So you're going to read them from left to right. So this would be 5 is greater than 3. Okay, you read them left to right. Yeah. Yes. There's actually quite a lot having to do with inequalities than you guys think. So if I'm reading this one left to right, how would I read that?
3 is less than 5.
3 is less than 5. So if I'm going to read this one, what would I say? Mimi? 2 is greater than x. Okay, and Sophia, what about the last one?
Greater than or equal to 7.
S. X is greater than or equal to 7. Where did this or equal to come from? Joey?
Because the line underneath is to simulate a equal to, and then there's the usual sign for greater than.
Right, so if you don't remember from, I don't know, like 4th grade or whenever we learned it, that line underneath is where this or equal to come from. Now we, of course, can graph these last two.
All I remember was like a circle and like a dot.
Right. So if 2 was greater than x, where should I be putting some numbers? I definitely want to start at 2. So should I put an open circle or a closed circle at 2? But can it be 2?
Oh no, it can't.
It can't be. So it's going to be an open circle because x can't be 2. It's not or equal to. And then where should I be shading? Should I be going up or should I be going down?
Down.
Because 2 is greater, then yeah, it's going to be everything else this way is the way that you would shade, or maybe you can highlight or just draw an arrow that way. So it's an open circle because it's not or equal to. Right now? Indeed. So what if I wanted to graph this one on a number line? Now, some people like putting 0 in the middle. It doesn't actually really matter considering the fact that we're comparing it to 7. If you want to put 7 in the middle, that's totally okay. Because we all know how number lines work. So you can put 0 in the middle, but that just means your number lines can be really big if you're dealing with big numbers. So am I going to have an open or closed circle at 0?
Closed.
Why is it going to be closed?
Because it can equal to 7.
So this or equal to is why we have a closed circle. Because we're saying, yes, it could equal 7. That could be one of the possibilities of what x is. And then, which way do we want to be going up? Do we want to be going down?
Up.
We want to be going up because it's going to be greater than, so 8, 9, 10.3. So we're going up.
Why is your screen like tilted like the line?
So when I'm recording, because of the way that it's essentially, it's not recording straight, it's slightly tilted to make sure I can get the board, it just the angle works out that way. Yeah.
Can I have the opposite end
All right. How do we feel about just this stuff in general? We're doing okay? All right. And let me erase this, and let's get into harder stuff.
It's not.
So sometimes when graphing things, especially on a number line, you might see things essentially kind of be limited in how they can be graphed. So let's say I'm trying to just figure out exactly how many sodas I can drink in 5 minutes. And for some reason I'm in some sort of competition where I can only count a whole can of soda. So maybe I can only drink between 1 and, 3. So then if I want to graph this, my domain is limited to being between 1 and 3, but I'm also being limited to whole numbers. And obviously I'm also limited to positive numbers.
So you can't drink half of the soda.
Right, so maybe I'm in some sort of competition where we're only counting the full soda.
What if you did like 3 sodas and 75%?
Well, then it's only 3 sodas.
Then it's only 3 sodas.
Oh, it's that.
This probably won't pop up too much, but just wanted to let you know so that if you are putting things on a number line and you are having to deal with whole numbers, this would be how you'd graph that. You'd actually only put the points down on that particular number.
Oh,
But I can't say you'll see this a whole bunch. But this kind of goes back to when we were talking about if things were continuous or discrete. So like this would be discrete. We can't have those middle 2.5 sort of numbers.
Why is it just letting it 1, 2, 3? 1, 2, 3.
Why not before?
Just for what the situation was. I mean, maybe if I make it 20 minutes, then it might be 1 through, 8. But not that I've tried drinking that many sodas in 5 minutes. But I just want something simple.
Soda.
Okay. We good?
No.
Okay, can I erase? Alright, something that we're going to be moving into if you want to start labeling your paper is we're going to be moving into essentially solving for x with inequalities. So it'll be pretty much similar to solving for x in any sort of equation, just now we have an inequality sign instead of an equal sign. Can I erase?
Yes.
So we'll just dive in with a sample problem. So when we're looking at these, you essentially want to solve them the same way we would if it was an equal sign instead of an inequality sign. So if I want to solve for n, what do I do? Mimi? We're going to start by combining like terms, so we can combine the negative 5n plus 2n, which is negative 3n. Then what would I do?
Divide both sides by 3.
By negative 3. So here's something that's going to get a little tricky, though. Something that you have to watch for is anytime you multiply or divide by a negative, you're going to switch the direction of the sign. So instead of it going to the right, it's going to go to the left.
I like your twist. Thanks.
Yes.
For the 3 divided by negative 3, wouldn't it be 0?
Mm-mm.
Oh, no, 2 1.
It's negative 1. Yeah.
That doesn't cancel out.
Well, it does. So 3 over 3 does cancel out to be a 1. But because one of them was negative, that negative stays there. Because anything over itself is 1. Because you're essentially saying how many 3s fit into 3? 1 does. Or if I have 3 people, putting them into, no, that way it doesn't work.
Containers.
3 containers, yeah, each container gets 1. That's why it works. Now, the thing with inequalities is we never get to leave it like this. It's always solve and graph. So in which case, then we can just graph these because we know how to. So we solved it. Open or close circle at negative 1? Open. Because n can't be 1. Or sorry, negative 1. Then which way do I go?
That
Wait,
Well-
less than.
Well, just think about, like, which way makes sense? Would negative make sense? 0 make sense here, or negative 2 make sense here? Negative 2 would make sense here, so I'm going to go this way. And it's probably always a little bit harder when you're dealing with negatives. Compare them. Alright, you guys think you can get into harder ones? Yeah?
Wait, I don't understand why the circle would be open or closed.
Okay.
Open is that it's not a possibility that it could be negative 1. Because it's have equal
And
to.
close
Because they can't equal to negative 1.
So it's going to be a close circle if you have this or equal to, because you're saying x is greater than 7 or it's equal to. So you're essentially saying on that number line that we're including 7. Whereas if it's just open, then 7 isn't included, but we want to include everything right next to it. All right, can I erase all this?
Yeah.
see.
And that open and closed circle, if that's something you're kind of forgetting, just write yourself a little note. That's something that you can easily always just remember and just memorize. All right, let's get a little bit tougher. Yeah, this one will be good. So even though it looks a little bit more complicated, everything we would have done to solve this if it was an equal sign pretty much still applies.
Yeah, I don't get when you said like switch the sign. When would you
So we only switch the sign if we're multiplying or dividing by negatives. So if I was just solving this normally, what would I do first?
distribute?
Caitlin?
Distribute the sign.
Yes, distribute the 7. So I get 14 minus 49R, and I still have all this other stuff out front.
You can add this 6 and 14.
Then I can compare, or sorry, I can combine the like terms. 6 and 14 become 20. Still have everything else. Subtract the 20 because it's adding.
It'd be 147.
147.
And then you divide by negative 49. And that's when you switch the thing, right?
So now that we're getting into dividing by a negative, we're going to switch the sign. So we're going to have regular R over here. The sign gets switched the other way. And then, I know no one knows 147 divided by 49. It happens to be 3. And it's negative because we have a negative. Okay. So really the only thing you need to start looking for, because all of this is stuff we've been doing, is this switching the signs if we're dividing or multiplying by a negative. If we're not multiplying or dividing by a negative, you keep it the same. So now that we have solved for it, it's always going to ask us to graph it. Brian, open or close circle?
Open.
Open. Because R cannot equal 3. And then which way do we go? That way?
Mhm.
Because negative 4 is less than, yeah, so that works. This way works.
We're saying that negative 3 is greater than R.
Yeah, because negative 3 is greater than, so R can be anything else down the line. It could be negative 3.1. It could be negative 4.8. It could be negative a
1,000.
billion.
It could be 1,000.
Anything else that way will work. Okay. You guys ready to try some on your own? Yeah? Alright. So I conveniently started the ones you're going to do this time, so you're doing number 4 and number 2. So you can move on to other ones if you want to, but just at least get number 2 and number 4 done. Oh, dear.
Wait, what? 2? Oh, the ones at the start.
Look at that, I was so organized this time.
Oh.
Why?
The stars are big.
Because I actually had time.
23rd? 25th.
Why do you actually write in such a interesting? Hi, Mr. Fudge. Hello.
It's like a collection of all the good ones.
Look at all these kids doing stuff after school so they have
Friday,
a better experience. I'm so proud of you guys. Except for you, you don't even say hi to me anymore.
I say hi to you now.
I
I've been
did.
making a
I
point.
do.
This morning.
You guys have 4 more minutes to do this.
Because I walked by and I was like, hey, Mr. Fudge, and you go, hey, Mr. Fudge.
I was ready to
What period is this?
7.
It's period 7.
You're having a meeting this afternoon?
Mhm.
I'm not available to make
Okay.
that. Here's the ruler.
Which one do we do?
I haven't had a chance to talk to this Well, you know, when you look at the grades, she's only missing a couple of assignments. I think she could put in more effort, but I also think that she struggled.
X equals 1. I put X equals 1. X is greater.
I haven't gone through everything.
No, 1 is greater. Oh yeah, well, X is less than 1.
Because you have the ability to grade them. Yes.
So you, I put
Am I concerned?
well, that way.
Not really.
Oh,
She
that's
has social skills. She has other things to help.
Yes. Yes, but I
That's right.
X is less than 1, so it's and then you do divide it by
Thank you, miss.
no, like, monsters are getting Go with the alligator.
Is this correct?
Oh yeah, you need to grab it. It's that one. Because X has to be greater. Oh, yeah. Okay, so 1 has to be greater.
Oh, right.
Oh, which way do I did it. Okay.
You failed.
Excuse me.
1 more minute on those.
Did you actually learn?
Back to what?
No, because you're excuse me.
Let's be greater. Yeah, I got it. It's warm. You only do the star one?
Yeah, just 2 and 4 for now. Because I want to make sure we get through everything.
2 and 4, right in the answer.
2 and 4.
What's that?
I mean, 2.
Because if you're doing 9 and 8.
That's like Kate right
Oh, wait.
All right, so let's take a look at number 2. So in number 2, what did we end up with when we solved it essentially? Sophia, what'd you get? 1x is less than what? Than 1? Is that what everyone else got?
Yeah.
here. So it's not 1x, right?
Well, so we can take that away, but
You can't do 1x.
we can do
Oh, yeah. Get
1x.
confused.
Okay, so is this what everyone got? No? Do we need to go over it?
Yes, that's what I got.
Okay. So
Can I
let's,
do it?
all right, shh. Let's quickly go over this. So I'm going to combine the like terms of the 6 x's together to get 12x, and I still have a plus 2. What am I going to do with that 2? Subtract.
Or divide.
So I still have a 12x and then a 12. Then what do I do?
Divide by 12 on each side.
Divide by 12. Do I need to change the sign?
No.
No, because there's no negatives. So that's how you would get that. So Brian, open or close circle?
I said, I put closed.
No.
It's not or equal to. So Brian, can x equal 1?
No.
No, it can't. So we're going to have an open circle. Then which way do we go?
Wait, what? Oh,
This way.
that
Or
way,
it's
that
negative.
way, that way, this way. Because one has to
It
be
equals
greater
that
than
way. Because 1 has to be greater, so it has to be negative.
1 has to be greater, so we're going to go this way. So if you're ever confused about which way to go, grab a number and put it in. So maybe -3. -3 is less than 1. Yes, that makes sense. So it's going to go this way.
I can please remember. Can I do that?
Are we good on number 2?
Yeah.
Okay.
No, because she has to be in the front. Unless you want to
Okay. What do we get for number 4? Jennifer. 2 is less than or equal to. Okay.
Isn't it
Other
greater than?
way.
It's
Other way?
Greater than or equal to.
Jennifer.
Like that?
Yeah.
Okay.
Yeah.
So 2 is greater than or equal to k. Do we need to go over that one?
Yes.
Okay. So combine like terms. 5k plus 4k. That's 9. Then, of course, you divide both sides by 9.
And you get 2.
Do I need to switch the sign?
No.
No, there's no negative. So we have that k is less than or greater or equal to, goodness, 9.
It's 2.
Oh, it's 2. Thank you. It's been a long day. Thank you. So, Brian, open or close circle. Can k equal 2?
And it has to equal 2. Yeah. When it has line in the bottom.
Since k can equal 2, we want to include it in our graph.
It has line in the bottom to say circle.
Wait, we can write a note for yourself.
All right, Jake, which way do I go?
You go left.
Do we agree left?
Yeah. Yeah, if it's facing away from the variable, it's left.
So because we want numbers that are being less than 2, if I take negative 2 and put it in, that's going to work. So that confirms that it's going to be that way. How do we feel with these?
Good.
Are we ready for things to get weird?
No.
Things are barely gonna get weird.
Barely. I think this is hard.
All right. Flip over the page.
Okay.
Oh dear.
You'll notice there's 2 more that are starred.
Oh my god.
Oh, it's easy. Just
Distribute.
Do you guys want to try these on your own, or do you want to do them together?
No, on our own. I think we should try. Yeah, please, just give us 2 minutes.
Okay, all right.
motivated.
2 minutes. Try number 21 on your own. Go.
42k, right?
Yeah.
42k.
Negative 42.
Yeah, I did. Plus
Plus 13.
13k. It's darling.
Oh wait, no.
42.
I was thinking of
These would cancel out.
No.
The 40, negative 42k, and 42k.
No, because you still need a K.
The k would stay. The k would be 1. Yeah, it would be 1k. Okay.
And it'd be, and then there'd be
The 7 and
1.
1 plus k.
One.
No.
Less than 30.
It is a false statement. You can't do like
I'm a mathematician.
It's false. I agree with false.
Why
does that equal to 2? Negative 2 minus 1. Wait, I have a question. What's negative 2 minus 1? I always get
Negative 3.
What am I doing? Okay, I'm so confused.
All right. I'm already hearing grumblings.
Yeah.
Me and Art are good at smart.
Okay. So let's start going through this. What am I doing with this negative 6? Distributing it.
1 and 7.
Okay, so I have a negative 6 minus 42k. All right, what am I doing with this 7? Distributing again. So plus 7 plus 42k is less than or equal to negative 2. We good so far? Okay, let's start combining things. What can I combine? All right, Ingrid.
Negative 60 and 7.
Negative 6 and 7, put them
Wait,
together
1.
to get 1. Okay. Then what? Brian?
Negative 42 plus positive 42.
Wait,
Those two cancel each other out.
They cancel each other out. So 42k cancel out with a negative 42k. Now, anytime your variable cancels out, you already know it's going to be what or what?
0 or 5.
It's either going to be no solution or infinite. Those always come back. So the 42 cancel out.
She did it with the other one. She got it.
So automatically with the k's canceling out, it's either going to be infinite or no solution. Now, is this a true statement?
No, it's not.
So because it's false, what do we call it?
No solution.
No solution.
another one we did.
Yeah, because on the last one I said that would cancel out. You said it wouldn't.
No, because
cancel out.
it didn't cancel out because it was dividing. That equals 1. It's not canceling out. This though, minus 42
No, 'cause
plus
it's 3 and
42
negative.
does equal 0.
But it would cancel out.
So I mean, yeah, 0k is just 0. You don't need to show plus 0. All right, 2 minutes. Try number 22. Go.
Oh,
Spawning.
Oh, God bless you. Thank you.
Me voy a morir.
Negative 4 would be negative 1. Negative. It's plus.
Why weren't you putting it down the whole time?
He did, it's the same.
Oh, wow.
He did write it down, he was gonna try and use that.
Well, then you have it written down. Use what's on your paper.
I'm out of here.
I think I did. What?
1 more minute.
Negative x positive. So basically just
What would negative 2 2x be?
4x. Because the negatives cancel out.
I decided.
Wait, plus?
Yeah. Yeah. Plus 4x.
So if it's negative 2 plus 4x.
No, it would be a negative 4 plus 4x.
Negative 4 plus.
Oh, that's what I meant.
That's what I got. Oh, only 51 minutes.
Negatives are so confusing.
Oh, yeah.
Can we just watch our
50 minutes.
I know what I'm gonna do.
A truck driver. I know.
All right. So let's take a look at this one. I didn't hear as much grumbling this time. So, what do I do with that negative 2?
You distribute.
We're going to distribute it. So I get a negative 4 plus 4x. What do I do with this negative 4? So I have a negative 4x minus 20 is less than or equal to a negative 24.
Wouldn't the 4x and the negative 4x?
Ooh, so I have right here, Diego, I have a 4x minus 4x. That cancels out because that just goes to 0. So automatically in your brain, you're like, okay, it's either infinite solutions or no solutions. So now I can find everything else. Negative 4 minus 20, negative 24. Is this true?
Yes.
Yes.
Te dije, no me haces caso.
Wait, no, it's infinite.
Either or.
I did this myself, just so you know.
Now, shh.
There's the same thing on the other side.
Now, the last one, obviously you can't graph no solutions. Can you graph infinite?
Yes.
Yeah, you can. It would look like this.
I go.
You just like highlight everything. It's everything. It's all real numbers. All numbers that actually exist. So you can't graph no solution, but you can graph infinite solutions. It's just everywhere. How do we feel with these?
Perfect.
Okay.
Except I hate the negatives and positives. So that's what I get.
Yeah. Okay. You ready for things to get weirder?
Yes.
Things are gonna get weird.
I always start you guys off with easy stuff.
You do.
You have to understand that.
We always start with like kindergarten.
start with hard stuff and then go to the easy. So then we go proud that we're learning.
College first, go down.
Let me find one that would scare you guys.
Go from like really complicated math to
It's already
Math. Once fear. All began with
11. Way down.
Okay. How many of you know what this is? Oh yeah, what is this? Elias, sorry.
well, it's like the absolute value.
I remember this.
Alright, shh. I have a lot of cross-talking. Let's keep it down so people can hear each other. So this is called absolute value.
And then it would be like 3 or something.
Alright, hold on. Shh. Don't get ahead of everyone. Because some people have experience with this and some people don't. Now what the absolute value really means is the distance from 0. Okay? But what most people remember is make it positive. That's normally the general thing.
Positive, keep it
If it's positive, you keep it positive. If it's negative, you make it positive. Yeah?
So then say
Equals 3.
Spaces from 0.
Yeah,
Because
yeah.
negative 3 is 3 spaces away from 0.
It can't be negative,
It can't be negative. Because you're saying how far away it is from
right?
something.
Right now you said normally, so I thought it was like something special.
So it's like me over here saying I'm 3 feet away from my computer, and over here I'm 3 feet away from my computer. I'm just saying generally where I am.
Alright, negative 3 feet from my computer.
So you're in
No.
Wait, no, that was.
Here. No, there's like no possibility. Stop possibility. Oh, X.
So what if we had a variable on the inside? Ian, what could x be?
negative 8.
Or positive.
It could be -8 or
Positive.
+8.
So it would be plus minus 8.
So we could say +-8.
Oh. Because it's gonna go into our inequalities.
Yes, it is. Can I erase this?
Oh my god.
So what if we put this into inequalities? So if we put this into inequalities, just like how before, how we're not sure if the stuff on the inside actually was positive or negative to begin with, we kind of need to assume both. Just like last week how we were looking at, if something's squared and we got this number, we don't know if we started with a negative or positive number. So what you're going to do is split it up into 2 problems. So in one respect, we're going to assume that the stuff inside actually was negative. And in another way, we're going to assume the stuff inside was actually positive.
So what did it be? Like the.
Oh, yeah, sorry. Yes.
I don't think no one gets.
Alright, so now we can actually solve these normally. Oh, one last thing. When we assume negative, you actually switch the sign.
Oh no.
Sorry. There's so many things to keep track of with these.
Oh no. Never mind.
So I'll change this one to be one of those little really...
Oh, because you switched the sign?
Yeah.
Oh, because it's negative, right?
Because it's negative.
So you haven't done anything yet.
I know.
You
But it's because we assumed negative.
Oh, so you just here.
So we switched the sign.
What is this?
When you assume negative, you're going to switch the sign. So in one case, you assume that it was negative to begin with, and we'll switch the sign with that. And in another case, we'll assume it was positive, but you keep that the same. Isaac?
Do we also have to make n negative n?
No.
How do you assume? Yeah, how do you assume?
So it's in the same way that we essentially say that we're not sure what it could have been. So it's just like before how we saw that like, well, x was on the inside and it equals out 8. X could have been -8 or positive 8. So this is essentially saying we're not sure, we're covering all of our bases. So now we can essentially solve both of these. So in both of them, I'm dividing by a 4. So what do I do? Multiply both sides by 4. Which part?
Would cancel out the 4.
Which would cancel out the 4s. So n is still greater than or equal to a -12. And over here, n is going to be less than or equal to positive 12.
I see. Wait, but 4 times 4 would be.
No, but it's 4 times a 1/4. So that's why they cancel out.
Okay.
4. So whenever we do these, they're going to want us to graph them. You graph both. No, you don't have to make them separate colors. Because we're solving for the same variable, so we're essentially kind of giving a range of what n can be. So, Brian, open or close circles? Closed. Because n can equal -12 and n can equal positive 12. So, both of them are closed circles.
You should have a party.
Now, n is greater than -12. So from here, which way am I going? In or out?
Oh, all the way. In the middle.
I'm going towards the middle this way. And then from here, am I going that way or this way? I'm going to the left. So it's actually going to be all this stuff in the middle. So I'm essentially saying n is somewhere between -12 and 12. Which might happen. You might have a range of stuff. Oh, the number of bracelets I need to make tonight is between 4 and 8. You have a range there. Okay? And this is a good way actually for you to always check your answer if you did things correctly or not. They will always either go towards each other or away from each other. So if you're getting like one going this way and the other going that way, you did something wrong.
Wait, that's the answer, right?
Yeah, so this is it. So they're either always going to be going towards each other or away from each other. They're either converging or diverging. So if they're both ending up going the same way, you did something wrong.
Can we do it again?
We will.
How did this happen?
Because the 12.
So it all originates from the fact that we started with an absolute value, which is how we ended up essentially with 2 answers.
Because she tried 2 possibilities.
Because I had to assume that I don't know what the stuff on the inside was. I don't know if it really was negative to start with. So in one case I assumed, okay, maybe it was negative, but then we don't know. It could have been positive, and that's how we diverged in the beginning.
Couldn't you have done it without like that whole word? Because you know that if you put 12 in, like.
Because things always get more complicated, no. Like right now it might seem like, oh, we could have done that without doing all that work, but as things get more complicated, you'll want to follow these steps. Good question. All right. In which case, let me find one that will kind of scare you guys a little bit.
Why are you scaring us so much?
Because I want you guys to see what these are like.
Why can't we just like make like scariness? Why can't we make us overcome our fears by nature and not by human?
Okay, actually first, I want you to try number 2. Okay? So on this paper, you're just going to try number 2. And then I'll scare you. So just try number 2.
Wait, but as the variable.
You have 3 minutes just to do number 2.
Just number 2. Wait. Start 6.
Alright, we got number 1.
I already told you.
30 minutes.
Did she make that? Like there you can say. Wait, this one already has a -9. We didn't be a -9, so we don't have to
We do.
each time.
Because you have to remember, it's a -9 being multiplied, so we still don't know if the variable itself
Oh, it
was
was
negative or positive. So you have to assume just 2 for now. Well, I think we'll do number 4 together after.
Wow. No. Close it back. You're bringing it.
2 more minutes. Yep,
Can I go back?
of course.
Then they have all my kids. I'm trying to learn.
No, you're like, you have to have surgery.
I don't get
No one gets
Oh, you would make the -54, right? I don't know where you put the negative. Here it is. Oh, but I have.
But you have notes.
I don't get her. Oh, okay, you put the negative on the 3.
Can you assist us in solving this?
Just not just let her give us like a minute.
You guys have 1 more minute.
That's what you're doing.
I'm trying to figure it out.
It should be the other side of the table. I would get in how to change it before, because if there's more complicated stuff on the inside, you have to make sure you change it and so if you have like x plus 5 minus like 7 square root, like you don't understand.
So we need the inputs.
So now what I want so you're assuming that maybe all the stuff wasn't positive, was positive, so you're gonna solve one where it is positive. You'll solve one where it's negative. Do you remember last week we were doing the square root of and they're saying that well x squared is 4, so it's negative 2 squared. So that's what I was before it has to be positive or negative. It's kind of the same thing. We're not sure what went on if it's positive or negative.
Look, she said they fixed it. See where you are.
Well, I thought it was, well, isn't it, wait, what is the negative to, wait, the absolute value, I'm guessing the variable is a positive, and then the absolute.
Assume that. That's why we solve for null. That's how we enter that range. X is somewhere in this area.
You're gonna get it on
Yeah, of course. This isn't class. We're in grad school.
You don't have to
If I don't pass this class, I'll be so What happened? What?
All right, eyes up here. I know we're all kind of struggling with this. So remember, we have to account for the fact that we don't know what was going on the inside of that absolute value. The absolute value keeps positives positive and changes negatives to positive. So we don't know what that variable was, which is why we divide them up. So we have to assume, we have to solve for if it was negative, so switching the sign, and solve for a negative 54. And we also have to solve for if it was positive. So you have to solve for both of these separately.
Can you help us?
Well, how are we on that stuff? At least just separating them.
I don't know.
Because that's how you get rid of that absolute value sign. Good? Okay. And honestly, if you forget to switch the sign, which happens, then when you're graphing it, they're going to end up both going the same way and you'll know you did something wrong. And then you can just go back and check. So on both of them, what do I need to divide by? Dan?
No, I have a question.
Okay.
Why is the switching for negative?
So because we don't know what happened on the inside, because remember the absolute value sign says whatever's on the inside becomes positive. So we don't know because what if v is positive 1? Not that it really can be, but what if it's positive 1? Then negative 9 times that is ending up being positive. But what if it was negative 1? Because it's still positive. So we need to account for the fact that either one could have gone in. So that's how we account for is to make it negative, because it could have been negative. We just don't know. That absolute value took that away. All right. So I have a negative 9v on both sides. The negative 9 is multiplying. Joey, what do?
We can divide by negative 9.
Absolutely. Divide by negative 9. So v is greater than or equal to, what is that, 6?
Yeah.
Okay. Same thing on this side. So v is less than or equal to negative 6.
How is the positive one negative and negative? Oh wait, never mind.
Because that negative 9. Right, because we were dividing by that negative.
No, I wasn't questioning.
Yeah.
Try to make it the same. We'll make it.
Okay. Shh. All right, Isaac, what do we do?
Since on the right side, since you're divided by a negative, doesn't the sign switch?
Ooh, good point. Thank you. Oh, actually, it would switch for both of them, wouldn't it?
Yeah.
Thank you. So this way goes that way, this way goes this way.
When did you do that?
Well, he's right. We would have gotten it wrong otherwise.
Oh, because that one's negative.
Because we divided by negative
See,
numbers.
you assumed wrong.
No, it's not that I assumed wrong. I forgot the rule that when we divide by negative numbers, you have to switch the sign.
Oh, I thought you said assuming, so I thought you could have gone wrong.
No, it's because we divided by a negative number. Okay. So, are we dealing with open or closed circles?
Close.
Closed. So there's going to be one at positive 6 and one at negative 6.
And you could be inside everything.
Well, is it inside?
No.
It has to.
No, it doesn't because it depends on the sign.
Yes, inside.
So it go outward.
No, it would be.
It's less than 6 and it's greater than negative 6. So this one is
Yeah,
inside.
this one. But it
Told you.
But tú dices que siempre tiene que ser así.
No, I said this.
I mean,
So this
you said
one's-
it's always-
And remember, that means we probably did something okay because it's either going to go towards each other or it's going to go away from each other.
My question was, can they go away?
Yes, they can.
Yes.
They can go away from each
So
other.
if the sign-
Because you're essentially saying it can be anything except this range in the middle. And that does happen. And we're actually going to be talking about that next. Okay. I think
There we go.
okay. Eyes up here really quick. Just in the effort of saving time, we're gonna skip doing number 6 like I had planned. The reason I had wanted us to do number 6 was because in most of the problems we've been working out, you've been getting pretty much the same numbers, a positive 6 or a negative 6. But it doesn't always have to be like that. You could have x is greater than or equal to 2, and then x is less than or equal to 5. That's a bad 5. So it doesn't always have to be the same numbers.
It would be inside 5, right?
That one, yes, would be also inside.
For example, for like 6, if you were separating into two, like the negative and the positive, when you're doing the negative, would it be negative, like x minus 5?
No, remember, you're changing that 9 then. You change what's on the other side.
You just changed the outside?
You just change the other side. So on this one, we changed just that 54. And actually, we were talking about it at table 4, because if you change one, like technically you could change just one sign, but as things get more complicated, it might be more work to change everything over here. Because you might have some complicated, like, x plus -3 divided by whatever, square rooted with, and you'd have to change everything in that sign opposed to just changing the 54. So it's just easier to just change the stuff that's on the other side. Alrighty. So now we're actually going to take a look at when they go together and when they go apart and what we call those. Huh?
Are we done with the lesson?
No, this is just like an additive in case this appears. It really isn't stuff to solve for, but I just wanted to show you this. So start adding this to your notes. This may be not something you're actually tested on, but I just want you to be familiar with the forms it might be in. So conjunctions means this, you're essentially going to have an inside range. These numbers are going to come together. So when I graph them, it's going to be in the middle.
You can say it all over again.
Sure. So we call it a conjunction when we have essentially an inside range. So x is greater than 5, but it's also less than 9. So this is another way of writing
Oh, okay.
both things separately. It's like we squish them together.
Oh.
So if they come together in the middle, we call it a conjunction.
Come together.
I'm gonna write down the word. Oh no, my handwriting's getting sloppy. Mine's always sloppy.
My handwriting is
So if you can combine it into one statement, 5 is less than x and is less than 9, and it's a conjunction, it's going to be coming together in the middle. And you technically can separate them into two statements. Disjunctions are the ones that we are going to be going away from each other. And those you can actually read as x is greater than 4 or x can be less than 2.
Oh, because it could be both. You could say it both ways.
You can say it both ways. So you normally read this one with an and. 5 is less than x and x is less than 9. Whereas this one you have an or statement. X is greater than 4 or x is less than 2.
But when you have to say both of them, you can't just say one of them.
No, because you're essentially giving that range. It's
And because if it's or, then you can choose one of them. It's like saying you can only choose one.
you're essentially saying it to say that we're discluding everything in the middle here.
I'll cut that or meant like only one. Choose one.
Well, we're saying x is somewhere in here. We're not sure.
that makes sense.
So the conjunction, we're saying x is somewhere between here. Disjunction, we're saying x is pretty much everywhere else except between here.
So no.
So not 2.2, not 3, not 3.8, but pretty much everywhere else.
Not 3.99.
Not 3.9, not like as close as you can possibly. In fact, it's not even 4. It's not an or equal to.
It's not even 4 now.
Not even
So this might pop up here and there as you get farther in algebra, but it may not be something you're actually tested on. Okay. You guys ready for things to get two-dimensional?
No. How are you supposed to do that?
Graphs.
How are we supposed to do what?
Graphs.
Gracias.
All right. Grab the graph paper I told you to grab.
Just guess. Maybe 2, 5.
I was gonna give her
Don't need that.
GAP.
Number 1.
I was like, I don't have.
Oh, you're losing then.
It's almost 3.
I was like, on my foot.
Alright, well,
He's right, not a story.
Oh, I get
What did you think you Oh.
alright. So make yourself a nice little graph.
Oh, I thought that was just color. I was like, what? Wait, I know what that means. You line them up and then you.
The line is in the way.
This is.
So we're going back to systems essentially. Now, the first way I taught you to solve systems was with graphing. Now, what did it mean to graph a system? What exactly was the solution? Mimi?
The point where the 2 lines.
Exactly. So the solution to a system is where the lines cross, essentially. So let's refresh ourselves. If I'm solving by graphing, what's my starting point for this one?
2.
At positive 2. And then what's my slope?
1.
At 1. So I'm going to go up 1, over 1 each time. And we can make ourselves a pretty little line.
Wait, that's confusing.
Wow.
Oh wait, no, never
Like
mind.
a line. Maybe a line. You said 3D.
Now, how do I graph the second one? Yeah. Start at negative 2. Then what? Up 1, over 2. So this might not have been a good one for me to start us off with, but that's okay. So they'll cross somewhere down here.
What?
Sorry. I'll come up with a better example one.
They never cross.
Up one?
They do. They just are going
Oh, I
off our
get
graph. This is really just for review for us, anyways.
Okay. They cross like all the way down there.
Yeah, they cross somewhere down there.
So it doesn't matter if we don't do it. Like,
Well, we graphed it.
okay.
I don't know what you're doing.
Neither do I. I think it would be very. Yeah, so you whatever.
Eso es malo,
What?
Okay.
Can you forgive me?
All right. Do we feel comfortable with remembering how to graph systems?
I just kind of forgot it.
Kind of. Okay.
Show us a better example. Like a real example. Yeah. No, just stop.
Fine.
Thank you. We love you. We hate you all.
If you want a better one, let's just change the slope. So still starting at -2, up 1, over 1. So it would cross kind of over there. So it's okay, we're not actually trying to find a solution. We're just trying to remind ourselves that they cross somewhere.
The other line.
Calm down. Calm down. You guys are wasting a lot more time complaining.
You complain.
Joey.
I went and just went ahead and figured out it's -8 and -6.
Cool. All right. So this is just to remind us how to graph these. When we're graphing inequalities in this way, it's actually going to be kind of a range on our graph. There's not going to be a specific point. So the only way you can do solving inequality systems is by graphing. Okay, so you always have to go back to that. So draw yourself a nice little graph again. Draw yourself a new little graph.
Oh, I saw what it's got.
Okay. All right, so we're going to go fairly quickly. We're going to go through this one together. I'm going to have you guys try one on your own, and then we're going to start the quiz.
Holy crap.
I would recommend using different colors to keep it straight in your brain.
What's that?
So every table has colors. Use them. All right. Ladies, wasting time. So we're going to be starting just by graphing this normally. So where do I start? At 2.
We use the same equation.
Yeah.
Yeah, they all are.
What's my slope? 1. So I go up 1, over 1. Don't draw your line yet, though.
Oh, okay, that's it. Like, it looks the same.
Have you seen this?
Okay. So that part about finding essentially where it goes is going to be the same. Now, if we were just on a normal number line, is this going to be open or closed circle? Closed. So the way we show this on this graph is I'm going to be drawing a solid line through all of these. I'll show you in a second. So because it's or equal to, it's going to be a solid line.
Oh, because
Because it's or equal to. So I want to include everything along there. So by putting a solid line, I'm saying every point along this line is included.
Oh.
Wait, but in the first one you did the same thing.
That was just review. So stop thinking about that last one. That was just review.
This was just reviewing what we were doing last time. So get your brain working.
So now we have to think about essentially which way it goes. So what you're going to need to do, just like before how I was saying, if you can't remember which way it's going to go, pick a point on one side and see if it works or not. We're going to do that exact same thing. So we need to pick a point on either side and see if it works or not. My favorite to choose is 0, 0 because it tends to make things easy. So unless the line goes through 0, 0, I like using 0, 0 as my sample point. So let's try 0, 0. So I'm going to take 0, 0, put it in for y, put it in for x, and see if it works.
No, it doesn't.
Is 0 less than or equal to 2?
Yeah.
Yes.
Oh wait.
It's
yeah.
less than. We'll count it. So since 0, 0 worked, I'm going to shade that side with whatever color you chose to do for that line. Because you're going to choose a different color for the other one.
Yeah, but if there was only 0, 0, not right.
No, 0, 0 was the test
Oh, to see.
if this side works. And shade fairly lightly. Doesn't need to be super hard. Okay, if I'm graphing this next one, where do I start? At -2. What's my slope?
1 to left 2.
Right, so I can either go up 1 to the left 2, or I can go down 1 to the right 2. Or both. Now don't draw your line yet. Just put those points in. Now, is this an or equal to?
No, it's
No, it's going to be an open circle. So the way that works is you're drawing a dashed line through it to essentially say everything on this line doesn't count. So we're going to do a dashed line. So draw dashes. Dash, 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 dash.
what is that saying?
Because so that's saying everything on this line does not count. Because it's that open circle, essentially. Everything right next to it counts, but everything on this line is not part of it.
So everything outside except.
So this is our equivalent of the open circle. So that dash line is an open circle, essentially. Saying everything on this line is not actually part of the answer, but technically everything next to it is.
Just put a dash in between all the things.
Yeah, you just put, I mean, it's just a dash line. They don't have to technically go between the points, they can go through them. You're just showing that it's not solid. So now, I need to figure out if I need to shade this side of the line or that side of the line. So what point do I like to use to test? 0, 0. So let's try that. So I'm going to put in a 0 for y, and I'm going to put in a 0 for x, and we'll see if it works. Does it work?
Yeah.
So everything above that line, so everything on the side of 0, 0 is going to be shaded.
Yeah.
So this is why I like to use colors. It gets really confusing if you're not using different colors. they overlap. So the actual solution is where these areas essentially overlap. So this is why I like using colors that will like overlap it in a pretty way. So like the red and the blue will come together to make purple or something. But you can kind of do whatever you want. So the area where they overlap is the solution. So the solution to both of those is any point within this area.
So what does that mean?
So any point within this area will work in both of those. So if I chose a point at, I don't know, 2, -1, that'll work in both of these. It's saying that any point within here is a solution to both of
And the
those.
one that's only blue, that means it'll only work on the blue solution.
Right. Right. So yeah, these ones will only work in blue, these ones will only work in red.
And then the white part, no.
And then the white will work in none. That's a good way to sum it up. Go ahead. Okay. Do you guys want to try one on your own, or would you rather have more time for your quiz?
I'd rather have more time for my quiz.
Quiz? Okay. All right.